Example 4, we do it a little bit of everything. Example 4 says find all the zeros, find all the vertical asymptotes, find the holes and the horizontal asymptotes of the functions, and we're nearly finished, I believe. Maybe this lesson wasn't as long as I thought. And I've done you the favor, I've already factored it to save time. F of x equals x squared plus 2x minus 3. If you can do this problem, you can do pretty much everything that's going to be on your homework. Over x to the third plus x squared minus 10x plus 8, which is equal to, in factored form, x minus 1 times x plus 3 over minus 1 minus 2 plus 4. I'll slow down so you can copy down if you like. So here we go. Again, it asks us to find zeros, vertical asymptotes, holes, horizontal asymptotes, pretty much the works. First off, let's start out with zeros. And when I say zeros, I want x-intercepts and y-intercepts. X-intercepts, yeah, pretty easy. Well, hang on. X-intercepts is what makes the function equal 0. So this divided by this is 0, so your x-intercepts, we're worried about the tops. Makes sense? So your x-intercepts, we got to be careful here though. Is it x equals 1 and x equals negative 3? No, x can't be 1 because that would make the bottom undefined. So our only x-intercept is at negative 3. Y-intercept. Which function would you use for the y-intercept? Because what do you do to find your y-intercept? Plug in 0 for x to find y-intercept. So which one's going to be easier to plug in 0 for x? First or second? I would do it the first one. Because x squared, 2 times x, all that stuff's going to be 0, and so negative 3/8. So y equals negative 3/8 or negative 0.375. That's where it's going to cross your y-axis. So we have an x-intercept, we have a y-intercept. Now let's look for vertical asymptotes. Just to find y-intercept, plug in 0 for x. So 0 plus 0 minus 3 on top, and then that's fine. Vertical asymptotes, holes, I would use the second. Factored form. A vertical asymptote appears when you have something that's a factor of the bottom and what else? Something that's a factor of the bottom and a factor of the top, or not a factor of the top? Not. Factor of the bottom, not a factor of the top. So you have a vertical asymptote at x equals 2 and at x equals 4. Negative 4. Try it again. Right. Makes sense. Is your function, is your graph defined at those two values? If you plug in 2 and negative 4 into your function, will you get numbers? 0 on bottom. It's undefined at those values. Again, the reason for that is you've got this line, your graph gets closer and closer and closer to it, but it doesn't cross it. Makes sense. Your function is not, the solid lines is your graph. Dotted line is not part of your graph, that's these asymptotes. Holes. Where do we have a hole at? X equals 1. Factor of the bottom and factor of the top. Makes sense. So do you see why that's not going to be an x-intercept? Because what your graph does at x equals 1 is it comes up to it, it's got a hole which we represent with a circle, and then it keeps going. That's the reason you don't have an x-intercept there. Finally, it asks for end behavior. This is how I want you to describe end behavior. As x approaches positive infinity, y approaches whatever, and as x approaches negative infinity, y approaches whatever. These are easy though. In behavior, all you got to do is focus on your highest powers. In this case, x squared over x to the third. And I'll slow down so y'all can catch up. I want y'all to watch this. X squared over x to the third. You're only worried about your highest powers. The rest of, pretty much the reason why, again, towards negative infinity and positive infinity, x squared and x to the third do more for this function than any of this other number stuff after it, because the x gets so big. X squared over x to the third, y'all simplify that for me. 1 over x. So as x gets really, really, really big, 1 over a million, 1 over a trillion, what does y approach? 0. As x gets really small, negative 1 million, it also approaches 0 in that direction. So out towards the end of your graph, you should get closer and closer to your x-axis. It should level off. Then it would be 1. X squared over x squared is the same thing as 1, right? If it's just x squared over x squared, it'd be 1 for both of them, yeah. Because there's no way you could plug in x's there. There's no way you could plug in infinities. So any questions about any other questions? If not, last thing, other asymptotes. This goes along with that third case. What if we have y equals 2x and we plug in infinity? Well, it goes to infinity. You actually do have asymptote lines there. We do have to remember the big little concept. So here we go. This third case, when the degree of the top is greater than the bottom, we saw that we had no horizontal asymptotes. However, if we divide the top by the bottom, we can find out what type of asymptote we have. Even though we don't have horizontal asymptotes, we still have asymptotes. Describe the end behavior for each rational function. I want to graph this and show it to you. Okay. On the first example, what I've done, 2x squared minus 1 over x plus 3, graphed it. Look at it. As x approaches positive infinity and as x approaches negative infinity, look what actually happens. As you get to closer to positive infinity, the graphs before, if you'd actually graphed them, are going to level out at maybe x equals or y equals 0 on both sides. It might level out as y equals 1 on both sides, but you had horizontal asymptotes. Here it doesn't level out. You've got this graph that comes up. Do you notice you have a vertical asymptote? Where is that vertical asymptote? By looking at your equation. -3. At -3, we got this vertical asymptote that we get closer to and we shoot down. We get closer to coming from this side, but we shoot up. But we're wanting to know about end behavior. As we approach positive infinity, as we approach negative infinity, look what actually happens. You see that our graph kind of gets closer and closer to a line. And we see this happen a lot, but only toward the extremes, only to positive infinity and negative infinity.